Hello there students, welcome to this lesson where we'll be looking at a complex question under nature of roots. What are roots? Roots are x-intercepts. This is where the graph cuts the x-axis or where it touches the x-axis if the graph has a turning point, for instance, in a case of a parabola or a cubic graph. What is the question in this case? Take a look. Now that we know what the question is, remember inquiry is about asking yourself questions about the question so that you can generate a solution. All right, let us look at the board here and let us see what we have. We have two equations. The question that we want to generate now is, what are the two equations representing for us? Functions, right? What type of function is this one? It's a parabola. What type of function is that one? It's a parabola. Concavity, we can also read off concavity by just looking at the equations. What is the concavity of this parabola? It is concave up. It looks like that. What is the concavity of that parabola? It's concave up. It looks like that. Yes? So R and M, and we're given a restriction, as you saw, that your R is greater than 0 and your M is also greater than 0. These are positive real numbers. However, looking at the two functions, the two equations, here's your R here, here's your M there. It's a coefficient of X. Here's your constant, here's your constant there. Okay, so if we have to link the two equations and being told that the roots are real and equal, we can deduce that R is equal to M. So whatever solutions that we arrive at the end of the maths that we're about to do, we must get here where whatever value we get for R will be also the value for M. Good. Roots are real and equal. Real means obviously they can be negative numbers, they can be 0, or they can be positive. Good. Now, if the roots are equal, what does it mean? We're going to use the discriminant, of course. However, it means that the discriminant is equal to 0. What did we say about the type of function that we're working with in this case? It's a parabola. It is concave up. Coefficient there is 1. The coefficient there is also 1. Right? So if the roots are equal, we know that the discriminant is 0. Therefore, this graph will only touch the x-axis, right? It will not intersect the x-axis at two different points because that will be outside this condition that we have. So our prediction of this type of setup graphically is this, that our parabola comes this way and it touches the x-axis there. Alternatively, it can be a parabola that comes that way and touches there. Okay. Or it can be a parabola that touches the origin and goes there. Okay, let us allow the mathematics to guide us in terms of the correct graph that represents the given information and also the question itself. Okay, let's find out for this equation, the discriminant. We know that it is b squared minus 4ac coming from the quadratic formula. Okay, so your b there is r, so it's r squared minus 4, a is 1, and your c in this case is represented by m, and this becomes r squared minus 4m. That is equal to 0. Okay, and the second equation, we have this guy. So let us find the discriminant for that. Your b there is m, so it's m squared minus 4 times your a is 1 times your c is r. What does that become? It's m squared minus 4r, and that is equal to 0. The roots are equal. Yes? Good. Now, we proceed by realizing that we have two equations with two unknowns. Okay? So r squared is equal to 4m. Okay? And here, m squared is equal to 4r. So by substitution as one of the techniques when you deal with simultaneous equations, you can use that technique then to proceed from here. Here we can make m the subject, divide by 4 both sides, okay? And m is equal to r squared over 4, and this guy, we neatly take him here, where we will have r squared over 4. We are squaring the m, so that will remain is equal to 4r. Okay, apply correctly the exponential law here of a power raised to a power. You have r to the power of. Okay, so we need to clean up, simplify what's going on here, multiply both sides by 16, and then transpose. Okay, and then we'll end up with r to the power of 4. 4 times 16 is 64, so it's minus 64r is equal to 0. Okay, so we've produced an equation that has only one variable, and we can therefore proceed to solve for r in this case. R for now is an HCF, and it's r cubed minus 64 that remains, which is equal to 0. Okay. R cannot be equal to 0. Remember, in the question, we are given the restriction that r is greater than 0. It's a positive number. It cannot also be equal to, it cannot be equal to 0, or it cannot be negative as well. So what are we left with? It's a difference of what here? I hear cubes. Good. So we need to factorize this. What does it become? R minus 4, r squared, product here, plus 4r plus the square of the last term, which is equal to 0. Okay, so what do we have? R will be equal to 4. Is this a positive number? Yes. And here, is there a solution that will come out of that guy? No solution. Why? Because the discriminant here will be what? Greater than 0, less than 0? Let's check. B squared, 4 squared is 16, minus, what is that? 4 times 1, 16. Okay, you end up with 16 minus 64, giving you a negative number. So if the discriminant is less than 0, you have what? Non-real roots for this guy. So our solution then for r is that one, 4. And what do we know? We also have the solution for m from that relationship there. So therefore, m is equal to 4. If you don't want to use that equation, you can go back to that one and use it to get your m. If you put your 4 there, 4 squared is 16, you divide it by 4, you still arrive at 4 for the value of m. Okay, so that was the question, right? And I believe that I was able to help you break it down to see what you need to look out for when you deal with nature of roots. Remember, the type of roots that you're dealing with determines what you do. If roots are equal, this is really the way in which you need to go about doing that. If roots are not equal, it would mean the discriminant definitely is greater than 0. Okay, and they will remain still real numbers. Okay, so that brings us to the end of this interesting question. And what can you now say? Which graph are we going to pick here that represents this two equations, because then it would mean we have the following. Just going to take that equation, x squared plus 4x plus 4 is equal to 0. Okay, so then which graph would be representing that equation? It will be the red graph, right? Because now your axis of symmetry, x is equal to negative b over 2a. That will be negative 4 over 2 times 1, which will give you a negative 2. So the symmetry line is right there for the red graph at negative 2. So then the correct one that graphically represents the situation is that. Okay, so please be aware and also effective with connecting equations to graphs where it's possible for you to do so, and generally it is, and it's a good skill also to go from the graph to an equation and see how that is interconnected and how it speaks to each other. All right, so thank you very much for tuning in. Go out there and excel in mathematics. Remember to subscribe, because that would mean more people will benefit from this channel. Thank you very much. Sharp, sharp.